with MOSFET, insyaAllah. Okay, so there'll be maybe another 2 classes only. Then, so I was thinking, but you still haven't marked your quiz 3, quiz 2 saya dah mark ke belum? Orang dapat belum?
Belum dapat.
Okay, so I have to mark quiz 2, quiz 3, then have to give you quiz 4. So on the quiz 4, do you want it this week or next week? Quiz 4 will be on BJT, huh?
Next week, please.
Okay, so I think what we'll do is we will do a class today, and then we have another class on Thursday, and finish the class for then next week and onwards you are free to to revise. Okay. Alright, so then your quiz 4 will be given next week. It will be on BJT. Closed book. I haven't made actually your exam question. So most probably I will do it next week, which means that we didn't have class. So if I have any tips I want to give you, I will tell you in the Telegram. Okay. So but it's open book. Okay. So but the one tips that I can tell you is that in the final exam, look at the marks. If the mark is a lot, you have to write as much as possible. If they say tell the characteristic, for example. So if the mark is 12, don't put only 2 or 3. So we say maybe if 12 marks, maybe 2 marks each, it'll be 6, right? So you need to estimate based on the marks. Because from previous semester, I've seen that sometimes 20 marks I put in one question. The student only write like one paragraph. So like 7, 8 lines. How can I give a lot of marks? So in the end, the student didn't get marks. So look at the kenapa dia tak charging? Look at the question, the marks carefully. Right. So, do you have question on the final exam?
Madam, we can both writing and typing for the final.
All will be handwritten, I think, best.
All handwritten.
Last time, hand. So you do it on a paper, then take a photo of it or scan it, and then submit the. Even if you want to, let's say if you want to type, possible as well. If you want to type, it's also okay. I can put into plagiarism software. If you're caught plagiarize, die. You will fail the final exam, then you fail the whole course. Okay. So inna lillahi wa inna ilaihi raji'un. So try not to be caught plagiarize. Okay. So, but I think from my question, it's not possible to plagiarize. Kadang ada, saya nampak juga student kadang pelik. Saya tengok last time when I mark the students, 3-4 students same answer. So the concept is open book, but you are not supposed to discuss with your friends. So bila saya tengok kenapa semua dah lah salah pula tu. So dah lah sama dan salah pun sama-sama. Then so okay, so I think they refer to the same source. Maknanya dia Google tu, they found the same source, so they use it. So but then salah pun, so they didn't get marks. So saya tak penalize. Kalau betul tu pun betul, I will maybe question. Kalau teruk sangat nampak sama tu, I will just call tiga-tiga tu, ataupun I will call tiga-tiga and interview separately. So if anything suspicious, what I will do is I will call you for an interview. Okay, so get ready. So don't just erase everything when you submit. So maybe I will call you for interview. You are supposed to answer, and you need to convince me that you understand. Bukannya copy paste from somewhere saja. And just make doa lah. You will not be in that situation. So because orang lain dah relax, awak pula kena interrogated lah. So just make doa that everything goes well. Okay, any more question? Have you all studied for the final exam for all courses?
Study for submission,
Submission apa?
preparing submission for other subject.
You have a lot of submission?
Yes.
Very.
Very? What do you mean by very? How many?
Very much.
How many very much? Tengok 3 je. Huh?
More than 3, madam. Multimedia, CNN, YP,
FYP, betul report.
3 je?
lab report. Oh,
Lab
Lepas
report.
tu ada quiz untuk lab, lepas tu ada quiz untuk
Quiz.
software. Lepas tu ada
Software.
report untuk software, madam.
Aduh lah. Memanglah terseksa lah sedikit. Tapi on the bright note, this maybe 1 or 2 last semester of your life in the university. So bertahanlah sedikit lagi, you know. Apa-apa pun, I mean, macam Nabi Muhammad SAW masa dekat perang Khandak tu kan. So memang dia ikat perut dia lah. Dia memang ikat perut dia 2 ikatan dengan batu. So memang all out lah untuk perang tu. So ni pun awak hanya ada 1 atau 2 semester je. So all out lah. Dan lepas tu awak nak rehat lah serehat-rehatnya. Now is a time to struggle. Okay. Alright. So all the best lah to all of you. So boleh je kalau tak nak quiz part. Saya okay je. Saya bahagia sebab saya tak payah tanda. Tapi kita ambil average of the 3 lah.
Kalau buat 3 je, ambil semua lah kan?
Ambil semua lah. Okay. Tak jawab takut tadi.
Make it optional, madam.
Apa?
Make it optional.
Optional. Bagus juga optional lah. So maknanya orang opted tak nak tu macam lega lah saya. Macam saya hanya tanda orang yang tak nak tu. That's a good idea. So do you all agree optional?
boleh, madam.
Siapa yang nak ambil quiz for? Beritahu saya now.
Saya half-half, madam.
Dia tak ada half-half. You have to choose either you want to do it or no. So, kalau semua orang pilih tak nak, dan saya tak payahlah buat soalan. Tapi kalau ada seorang nak buat, saya kenalah buat soalan. So,
On, madam.
Madam, bila quiz?
minggu depan. Kenapa masuk lambat?
Ni, settlekan project lab sikit. Tekan circuit. So,
Awak masuk lab ke apa? Simulation?
simulation online. So, sebab dia lag kan. So, dia take time. Sebab nak run software tu sampai tunjuk online.
Seksa je.
So, dia lag sikit.
Okay, it will be next week. So, kita ada kelas 1, 2 lepas tu habis. So, Solehin nak buat lah. Okay, Solehin nak buat. Orang lain? Jawab seorang satu. Kalau
Saya
tak,
follow Salim.
Azam pun nak kuis. Orang lain?
Tapi madam, apa dia punya
Scope.
soalan?
So,
BJT.
apa soalan dia BJT? Anything on BJT?
Madam.
final tu ada yang pasal research paper tu ke?
Research paper mana?
Yang hari tu madam ada cakap. Question based on research paper.
Bagus mengingatkan saya. Sampai saya buat note tu saya lupa dah. So, saya tak decide lagi. Maybe bagus idea awak, mungkin kita buat. Oh, tak payah buat ke macam mana? Now research paper. Paper exam. It depends. If I can find a good research paper to for question, I will do it. Kalau tak ni lah. Saya tak buat. So saya tak buat lagi kan. So kalau saya tak cari lagi, I don't know whether there is research paper yang related yang ni or ataupun tak. So saya tak ada jawapan untuk soalan tu. So orang lain macam mana ni? Siapa nak buat quiz lagi?
If madam nak buat for the final, then for the quiz for based on research paper juga.
Oh, so maknanya quiz 4 kena buat on based on research paper. Tak nak.
In case kalau
Okay. So
okay.
nak buat question on research paper ni needs a lot of time. Saya tak ada masa. So apa nama ni? Saya tak ada masa nak buat untuk dua-dua. So sebab saya kena cari research paper tu lagi, betul saya kena fikirkan soalan tu lagi. So kalau untuk exam mungkinlah saya sempat lagi nak fikir. Kalau quiz ni saya rasa sebab saya kena buat dua-dua. So saya lagi prefer concentrate effort masa saya dekat exam. So tapi tu pun tak sure lagi saya buat ke tak. So kalau keluar exam pun saya akan beritahu lah. Saya bagilah some tips ke. Maybe. Okay. So Hambali nak quiz ke tak? Jawablah soalan saya ni. Kalau tak jawab ni kan saya assume awak tak nak.
Tengok dulu lah markah quiz 3.
Tengok dulu markah. Tak tahu sempat ke tak. Maybe saya boleh mark dalam minggu ni quiz 2. Quiz 3 tak sempat. So okay, I will give you quiz 2 then after that quiz 3 memang tak sempat untuk saya tanda sebelum tu. So quiz 2 saya akan tanda. So you decide after saya bagi quiz 2. Kalau tak beritahu saya assume awak tak nak. Okay. So then I will take the average of the 3. Kalau 4 ni take the best 3 out of 4. Okay. Alright. So Faiz ingatkan saya untuk tanda quiz tu lah. Hopefully hari ni saya ada apa? Tanda ada trust fund pula. Okay, malam ni ke? Okay. Alright, so that's it. So let's share my screen. The attendance today will be the password for attendance today will be give me a password. Suggestion of password.
Naqasim.
Lockdown.
Huh? Lockdown.
Lockdown.
Okay lah, lockdown.
Saya baiklah kantin dengan ni pun buka lagi still.
Madam, kita nak lockdown sampai bila?
Awak nak lockdown sampai bila?
Dapat soalan macam budak-budak saja. Macam budak kecil saja.
Lockdown macam tak function ni, madam.
Tak function ke? Function lah.
Tak function. Hey.
Dia cakap kilang tak boleh buka. Lepas tu tiba-tiba last minute boleh buka.
Kilang? Wah, I think it's very tough. Tapi banyak cases kat kilang. Tapi sebab kilang ni kalau tak jalan, kilang tak boleh make profit. Orang tak ada kerja, ekonomi negara menurun. So it's very tough. Kalau kita duduk kat tempat dia pun duduk tempat yang apa. Kalau saya sebelum saya condemn apa-apalah management ke UIA management ke kerajaan ke sesiapa, saya akan letak diri saya kat situ and saya kena decide saya boleh buat tak decision yang betul. Kalau saya boleh decide buat decision betul, masa tu boleh condemn. Tapi kalau kita fikir, kalau kita duduk kat situ, it's easier to condemn rather than to come up with solution. So saya selalu fikir macam tu lah. So sebab kadang-kadang kita selalu fikir kita orang bawahan. Saya selalu fikir macam mana kalau kita jadi orang atasan. Jadi orang atasan ni tak senang. They have to make, macam for example UIA need to make macam decision untuk macam sejahtera komiti pasal all the SOP dalam UIA ni. Kejap meeting, kesian Dean. Saya macam tak ada kerja lain. Deputy Director pun kerjanya duduk meeting benda ni je. Macam benda lain banyak lagi benda-benda penting kena buat, tapi duduk meeting masa tu. Lepas tu anything salah orang condemn macam tu, without asking why or nasihat. Kalau memang salah tak apa, give nasihat. Tapi so overall memang perlukan ni MCO ni memang perlu. Memang kalau imagine kalau tak ada Solihin, can imagine kalau tak ada manusia keseluruhan ni kebanyakannya bodoh. Dia macam kecuali orang push dia tak harap untuk kebanyakan manusia ni dia pengikut. Orang bagi arahan tu dia buat. Dia bukan jenis yang macam nak proaktif ke change tu memang kebanyakan manusia macam tu. So jadi bila adanya rule ni, so orang akan jadi lebih takut. So kurang sikitlah orang kuranglah sikit orang untuk possibility untuk spread the virus. So kalau tak ada, tak boleh imagine semua orang keluar walaupun orang tahu benda tu bahaya and walaupun orang tahu benda tu macam dangerous and mudah merebak, tapi still orang keluar. So factory is a bit tricky sebabnya dia melibatkan, bukan sebab kita kata kita nak bagi special macam factory ni special, tapi kau tengok on the economy of negara dan juga tengok macam income of orang. So for example kalau factory tu tutup, sebab orang kerja private ni, kalau dia tak pergi, macam saya ada saudara, awak ada saudara kerja kat kilang?
Ada, madam.
So dia kalau dia tak kerja kilang, dia dapat duit tak?
Dapat.
Tak dapat.
Tapi tak ada OT. Dapat gaji basic tapi tak ada OT.
Kalau kerja kilang hak biasa, tu yang saya rasa saudara awak yang kerja kilang yang hak tinggi kot, engineer ke apa kan.
Operator.
Kalau kontrak lah.
Apa benda?
Kalau orang yang kontrak punya, yang based on gaji jam.
Kontrak, kebanyakan kontrak. Kalau hak yang kat bawah-bawah tu lah, yang tak ada education tinggi. Orang ni yang susah sebenarnya. Orang hak tak ada saving, tak ada apa kan. So macam dia gaji ikut hari. So macam kalau dia tak pergi, tengok jam, kalau tak ada maka tak adalah gaji dia. So can imagine kalau tu duduk 3 bulan, dia nak pergi makan apa ke anak dia, si dia. Saya ada saudara sebelah suami lah, dia kerja. So macam dia, so difficult. Sebab dia bergantung macam tu. Kalau dia sakit, dia tak pergi kerja, tak dapatlah duit. So jadi sebenarnya ramai pula tu, orang macam ni ramai sebab dia cheap labour kan. So macam orang dia akan pakai banyak kat dalam kilang. So macam mana dengan dia orang ni, sedangkan dia tak dapat subsidi kerajaan. Macam mungkin tahu dia orang dapat ke subsidi kerajaan lah? Tak tahu pula.
Kalau siapa yang bergalang PIN tu, saya tahu nanti sehari dia akan dapat 50. Tu je lah.
RM20?
50 kot. So dalam 14 hari dia akan dapat 700.
Satu family?
Orang yang bergalang PIN tu.
Apa? Gelamping?
Gelang kuarantin tu. Dia boleh mohon benda tu.
Gelang
Gelamping.
kuarantin. Gelang kuarantin. Tapi kalau dia tak gelang kuarantin tapi dia tak lagi kerja, factory dia tutup. Macam mana? Right? Dia sebab tu dia boleh bagi, tapi kilang kena sangat jaga SOP. Kena crazy jaga SOP. Dan benda tu boleh. So kerajaan kena make sure lah kilang tu kalau nak buka boleh, tapi dengan syarat dia kena jaga SOP. Sungguh-sungguh. Tapi memang banyak cases sebab bila dia tak jaga. Sebabnya dia orang boleh dengan syarat. Kalau tak, kerajaan denda lah mereka. Kan dia orang kaya lah, di kilang-kilang ni. Dia tak jaga SOP apa semua. Kilang patutnya kenakan a high sum of fee kat dia orang ni. So it's difficult sebenarnya. It's difficult. So macam it's difficult. Orang kerja-kerjaan ni no problem lah duduk cuma sekarang ni aku tengok lah dia Perdana Menteri cut dia keluar news lah dia 3 bulan allowance dia tak ambil lah. Aku tengok tu.
Saya dengar
Allowance ke
Syed
gaji,
Saddiq
madam?
madam.
Ha?
Allowance ke gaji?
Gaji ke allowance lah? Tak tahu rasa macam allowance.
Gaji. Gaji, madam.
Gaji. 3 bulan gaji tak ambil. Lepas tu pejabat awam pun tak tahu. Dia cut gaji. Dia cut allowance. Tapi itu gaji sebut allowance yang tu. So maknanya kalau macam saya ni macam 5 to 10% macam tu. So dia voluntarikan orang ni. Tapi for us, kita memang dah ada gaji pun. Kan mana kita tolak 5 ke 10% tu doesn't change much. Kecuali orang tu susah betul-betul. Tapi biasanya kalau orang dah tak susah mana. So maknanya saya dah fikir kat mana dia dapat 40 bilion tu untuk rupanya dia cut gaji. So okey lah. 5 to 10% okey lagi. Kalau cut 50% tu sakit lah. Tapi saya tengok Jusa A, awak tahu tak pasal Jusa ke ni. Jusa A ni dia ada Jusa C, B dengan A. Awak tahu tak? Do you know what that? Apa benda tu?
Tu macam rate jawatan.
Jawatan kerajaan
Tak
ya.
paling tinggi
Jusa A paling tinggi. Profesor Jusa C. Bawah tu dia ada start profesor dia dapat jusa dah. Sebelum profesor kita kalau academician ni dia bergantung pada kerajaan kat mana. Macam adik saya kat Mardi dia ada nombor-nombor kat belakang tapi depan itu lain. Macam kalau akademik ni tak payah. Tak masuk MOSFET kita ni.
12:15.
12:15. Kita patut habis pukul 1 dan don't worry. Okay. So MOSFET. So today we have finished before on BJT. Now we'll go through MOSFET. So MOSFET stands for metal oxide semiconductor. Metal oxide semiconductor. FET. Field effect transistor. So from the name you know how does it work. Okay. So kalau from this name also you can actually draw the structure of the MOSFET. So the structure will be metal oxide semiconductor. So dia memang structure dia macam tu. Tapi nowadays this metal they change it to kalau pergi tengok yang CMOS ke apa-apa tu they no longer use metal. Why? Because metal ni bila metal ni dia punya karakteristik tu dia senang lari. Lari tu maksudnya kalau panas if we heat it up, this metal can easily displace. Dia akan bergerak daripada tempat dia. So it's not very for theoretical physics is good. Tapi bila when they do actualnya, when there's some heating or anything, this metal can easily displace. So jadi therefore they found another material to what do you call it, to replace the metal. They use polysilicon. Okay, so if you do VLSI, most of the time, what are VLSI kan? Some of you.
Yes.
So they use polysilicon as the gate, right? So this metal oxide semiconductor. Oxide ni apa? Oxide is an insulator. So basically you have metal which is in conductor, then you sandwich with insulator, then at the bottom instead of metal you put semiconductor. Okay, semiconductor. So and field effect transistor, how it works is based on field effect. We learn about BJT. How it works is not on the field effect. How it works is like a diode, right? You forward bias a junction. But MOSFET ni, although it's also a transistor, meaning that you have 3 terminal and you can use it as an amplifier and you can use it as a switch. So sama je transistor BJT, it can do the same thing, but how it works is different. How do you get the amplification is different in MOSFET. Okay. So MOSFET become practical reality in 1970s. 1970s, saya baru lahir masa tu. The MOSFET compared to BJT can be very small. So cerita dia, the story was, I can't remember I told the story or no. First they do BJT. They found BJT first. Then later on they found MOSFET. They created this MOSFET. However, MOSFET technology and research goes faster in compared to BJT. So then it become mainstream. So all the transistors after that goes for MOSFET. Because number one, the technology goes faster, and number two, compared to BJT, MOSFET can be made very small. You can make a very small area on the IC chip. So you can use MOSFET in CMOS. And in IC, integrated chip, you know there are many, like millions of transistors. So million of transistors. So you need a lot of it. If it's small, then you can fit it into a very small chip. Sebut pasal chip ni teringat saya. Okay, tak nak rekod je. Teringat saya apa? Yang percaya benda tu. So, tapi masalahnya ramai meninggal. Adik saya kerja bukan houseman, MO dekat kampung dekat Besut tu lah. Dia duk cerita, ramai ada pakcik tu. Dia cerita baru semalam, ada pakcik tu dia suka pakai mask tutup kat bawah ni. Kau pernah tengok orang pakai mask kat sini tak tutup hidung? Pakcik tu macam dia macam orang nasihat dia, doktor semua nasihat dia buat tak tahu. Lepas tu dia siap boasting kata, oh anak dia ni pakar kardiologis dekat KL macam tu lah. Lepas tu tapi dia pakai macam tu. Lepas tu dia masuk, hari pertama masuk, hari ketiga meninggal. So macam it's difficult. So benda-benda ni perlukan knowledge. So tak boleh, because of kita punya kejahilan kita boleh membinasakan diri kita. So kita kena faham lah, kita orang cerdik pandai ni jangan duk ikut apa-apa based on scientific knowledge, and kena beritahu lah orang kampung semua. Okay. So IC chip. So therefore dengan MOSFET ni we can build VLSI. So VLSI, very large scale integration, with the integrated chip tu, everything based on MOSFET. Tapi sebenarnya tak betul, there is essentially no resistance or diode required. Dalam VLSI pun kita boleh buat resistor dengan diode juga dalam chip tu. Tapinya, so the basis of VLSI is MOSFET. Okay, so that's why here it's good to know how MOSFET works. So MOSFET is the basis of all integrated chip. So nowadays nothing, basically sangat rare lah, semua siap periuk nasi pun ada chip kan sekarang ni. Sebab dia nak measure sensor apa semua tu, periuk nasi pun ada chip. Semua benda, handphone, you can see around the printer, ada ke benda tak ada chip? Okay, jam manual tu tak ada, tapi jam digital pun ada chip. So everything around us, are based on this integrated chip, which is basis of the MOSFET. So okay, bila kita cerita pasal integrated chip, mostly we are talking about, kalau VLSI ni mostly on the digital 101010. So dia guna, kebanyakan VLSI ni diguna untuk switching. They use MOSFET as switching. Siapa ambil dah VLSI sini?
Ni madam.
So you know better than me, right? About VLSI. So they use MOSFET untuk apa? Azam?
Ya madam.
Dia apa VLSI guna MOSFET untuk apa?
Untuk yang logic gate tu.
Bina untuk logic gate. So how does the logic gate works? Basically just turning on and off, right?
Yes.
Yeah, so you build individual MOSFET to come up with a logic, which is in the end this logic will make choice whether it's 1 or 0. So that is digital. So VLSI mostly digital, but MOSFET can also be used in analog circuit. Analog circuit ni macam amplifier is analog. Okay, amplifier is analog. Analog ni dia bukan 1010. Tapi most of the ni VLSI ni memang 1010 lah. Dia memang dia on the apa logic. Logic gate ni memang tak ada line 1010. So okay, how does the MOSFET works? Okay, let's draw. Barulah. Okay. So from the name, so let's draw the before the structure. Let's draw this first. So you have metal, and then you have oxide, insulator, and then you have this semiconductor. Okay. So you have metal. Let's start with metal. Oxide, semiconductor. Now, let's say this apa nama ni, this semiconductor here is P-type. Okay, this is P-type. Okay, so if you apply a voltage here, ni metal kan, metal ni kita apply a voltage at the metal, a positive voltage. Okay, what happens inside here? What happens inside the semiconductor? Can anybody tell me?
The electron attracted to the positive terminal.
Okay, so this P-type, so the minority or majority of the electron?
Minority.
So the minority of the electron will be attracted to go here. Can the electron go here?
Seem like
No,
No, why not?
it's insulator.
Insulator.
Yes, good. So the electron will be attracted to go to this positive side, but it cannot go beyond the insulator. So it will just accumulate over here. Okay, so the minority, and you need to understand this is minority of electron accumulate. What happens to the majority carrier?
It will go down.
It will be repelled, right?
Repel
So
down.
the hole doesn't like this positive, so the hole will be repelled away from this surface. So we call this a surface. So this is a surface between oxide and semiconductor. So the electron will go there, and so this attraction of this electron to the positive charge, what is this called? This is called field effects, electric field. So whenever you're applying a positive voltage here, it means that there's electric field over here. And the electric field will go across this this insulator. So this electric field will go across this insulator, which then forces the electron to be attracted. So that's why the name is field effect, electric field effect. Electric field because there's no current, it's just electric field going across this insulator. So it means that, so let's say there's no insulator, there's no outside. This oxide is a insulator. Ni awak faham tak ni oxide apa? Do you know what kind of oxide is this? What is oxide?
Oxidized material.
Okay, what kind of oxidized material?
Silicon oxide.
Silicon.
Silicon oxide.
Silicon dioxide.
Dioxide.
Silicon dioxide. Okay, you have silicon. Silicon is here. This semiconductor here is silicon. The insulator is silicon dioxide. Silicon dioxide is no longer a semiconductor, it's a insulator. Okay, silicon dioxide. So silicon dioxide ni kat mana boleh jumpa banyak silicon dioxide? Kalau pergi pantai, pasir tu ialah silicon dioxide. So that's why kalau belajar VLSI design, awal-awal VLSI tu dia akan cerita macam mana you get pure silicon nak dapatkan wafer tu kan. So one way of it dia akan ambil pasir sebab tu MOSFET ni one of the thing that goes cepat ni sebab dia guna silicon, and silicon ni murah sebab you boleh buat silicon, pure silicon daripada pasir. Pasir you ambil and then you burn it off, keluarkan oxide. So sebab dia silicon dioxide ni kan. So kalau you keluarkan oksigen daripada situ, dia akan jadi pure silicon. So senang lah. So that's why kalau pembinaan MOSFET pun bagus sebab you ada silicon kat sini, you silicon dioxide. You can senang untuk change daripada silicon tu, you bakar atau you oxidize, letak oksigen, dia jadi silicon dioxide. Pure silicon, you oxidize it, become silicon dioxide. So, and silicon dioxide is a insulator. So, jadinya, jadi insulator ni kat sini. So jadi you have this field effect whereby this field effect is actually attracting the carriers to go to the surface. Now, so this region, okay, my question is, what happens if you don't have this oxide layer? Kalau macam ni je.
The electron will go to positive terminal.
So do you think you can have this field effect?
No.
No. So that's why the insulator is very crucial. So that's why if you look at the current technology, when they're trying to make MOSFET smaller and smaller and smaller, one of the things that they have to take into consideration is the choice of this this oxide layer. Sebab this oxide layer, it cannot be too thin. So this the thickness of the T-ox. The thickness of the oxide layer is important. If it's too thin, you want to make it very small, the MOSFET. So you make it smaller, kenalah the oxide also become thinner. The problem is when it's become too thin, it can no longer work as insulator. So dia macam elektron tu boleh jump ke terminal. When this electron are able to jump to go to the terminal, the device no longer works as a MOSFET. So it cannot work lah. So this part need to be an insulator. So that's why when they make a smaller and smaller smaller MOSFET, they will change the material. You can see they no longer use silicon dioxide. Nowadays for yang very small nano punya tu, they will use a different material of insulator over here. Why? So that it can be thin but still having a high, not sure, permittivity ke dielectric kot. Of the insulator. Okay, so that is all part of being a engineer kalau dalam bidang ni lah. Okay, so now so now you understand. So sebab kadang-kadang student saya pun tak faham student ni, orang cerita berjuta kali ni still dia buat benda yang sama, kesalahan yang sama, which is bila dia draw dalam exam ke quiz, dia draw tu dia terlupa letak insulator. Dia draw dia draw macam ni je. Definitely kosong. It cannot work.
Short
It's
circuit.
wrong, right? So dia terlupa nak letak insulator. Tak boleh. Insulator is one of the most important component in the MOSFET. Okay. Okay, now you understand how this field effect. So how does ni bukan MOSFET lagi. This is field effect. Okay. Now how does a MOSFET works? Before that, let me change. Kalau saya tukar ni kepada N-type. And I apply a negative voltage here. What happens?
Minority carrier which is whole will attracted to.
Cannot hear you. Tak jelas.
Minority carrier which is whole will be attracted to the negative terminal.
Okay. Will be
And the
attracted
negative terminal.
you need to say be careful, will attracted to the surface of oxide and semiconductor. Kalau kata attracted to negative terminal, takut orang faham dia pergi sini. Right? So then it will be attracted to the surface between the oxide and semiconductor. Then
The majority carrier which is electron will be repelled.
okay. So you understand the concept, huh? So it depends on what it depends on what do you call it? What voltage you apply here, and it depends on what are the majority or the carriers that you have inside the semiconductor. Okay. Now we understand that. So let's draw a MOSFET.
Madam, can we say junction of O and S outside dengan semiconductor? Is it a junction there?
Alamak. Is it a junction? Boleh lah. We can say it's a junction. Okay. Junction between this and this. Surface of the kadang-kadang dia kata surface of the semiconductor. Okay. So now let's draw the MOSFET. Okay, nak draw ni. Okay. So MOSFET dia sama juga. Except for dia ada 3 terminal, right? Yang tadi tu ada 1 je terminal kat atas kan. So MOSFET, like any transistor, have 3 terminals. What are the terminals of a MOSFET? Masa first year dulu, orang BRSI tak tahu ya Allah. Saya pun tahu Pak Anis. Azam.
The base dengan pada satu itu.
Apa terminal untuk MOSFET? Tak ingat.
Drain, source, gate.
Drain.
Okay. Drain, source and gate 3. Kalau nak pergi interview, make sure lah tahu benda tu. Kalau tidak, the first thing tak tahu, dia akan memang list awak terus. So there are 3 terminals. The terminals are the gate, the source and the drain. Gate, source and drain. Okay. 3. So asas dia sama. Asas dia you still have metal oxide semiconductor. So for example now, let's look at the drain and source. What is it? So let's say if this is N-type MOSFET, and dia panggil N-channel MOSFET or N-type MOSFET, NMOS. Dia bukan N-type, dia panggil NMOS. Kalau dia NMOS, can you tell me what's the doping here? Or what is the doping of the source and the drain? What is the doping of the source and the drain?
NPN?
N-type.
NPN?
NPN to BJT. Doping.
I mean,
Apa Azam?
N-type.
N-type, okay. So doping you only have N-type or P-type. So here, this is N. and N, and here it will be P.
Yeah,
Okay.
that's what I mean. Sorry.
So I'm asking the source and drain is the N only. So you have the source and the doping there. So why is it okay? So how does it work? Now you have the source and drain dope with N, and you have the substrate ini substrate. Dope with P, and then you have the insulator, you have the gate. Okay, now let's say we apply a voltage of a positive voltage here. Okay, what will happen?
Field effect. Electron attracted to the
Electron will be
junction
attract-
between oxide. Sorry, surface of between oxide and
So you have
semiconductor.
electron will be over going here, and then what else happens?
The holes repel.
Okay, then you have holes will be repelled away. Okay, so do we have current now?
Not yet.
Why not?
Where's the flow of the because the what is it, the insulator?
Apa maksud awak?
Because the insulator blocks the current. Well, if we are talking between the semiconductor and the gate lah.
Okay, so how do we get current here? What should we do in order for us to get current? Because MOSFET, it can become 1 or 0. 1 is when you allow when current flows. 0 when there's no current. Right? So how do you get current? Or VLSI?
From jump. There's a what is it? The electron actually form a channel between the source and drain.
So the channel is formed. So what next? So is there any current if the channel is formed?
Electron from S will go to P.
How?
If we apply voltage,
Where do you apply the voltage? What
at the
voltage
source or drain.
what voltage do you apply?
Selalunya source ke drain, right? So positive voltage to
Positive at
source.
source.
Huh?
Positive at source.
Positive at source. Biasanya source ni yang apa yang ground.
Ground.
So
Because
basically,
the name is source, I thought it was like okay, apply source voltage. Nope.
so normally your source ni you negative or you ground, and you apply a positive voltage here. So when you do that, how do you get current? So complete one, complete in a loop. So you have, so this going to the outer circuit positive ni, so they'll be connected out there. So electron will flow from here to the N type, going through the inversion channel, going to the drain, and then go to the outer circuit. So you have current. Okay, so now, so that's how you get current. So if you don't want any current, what do you do?
Just cut out the gate voltage.
Yeah, so if
Cut off.
if you put 0 volt at the gate, then there will be no accumulation of carriers over here, so you don't have channel. Therefore, if you look here, can you see two PN junction over here? Do you see a PN junction, 2 PN junction over here? 2 diode.
Yes.
Where?
Between substrate and substrate of P and S and substrate of P and the T.
Right? So because this is P and N. So can you see the diode is back-to-back diode?
clamping.
So what does it mean? Can current flow?
No.
Huh? Can current flow?
Cannot.
Cannot. So that's why one of the good thing about MOSFET is that because of this naturally happening in the structure of a MOSFET, if there's no inversion channel, it will be a very good zero because you cannot have, it's not possible for this to leak over here. So back to back diode. Okay. So the only current that the only way for current you have current is you need to have this inversion channel, and when you have electron accumulating at this area over here, we call it inversion channel. Why invert? It's inverting sebab kenapa nama dia invert, sebab kat sini kan P, so P ni banyak hole, sepatutnya semua tempat ni banyak hole, tapi because of you applying a positive voltage over here, you are inverting this area only daripada banyak hole kepada banyak elektron, and you invert that channel tu, inversion channel, sebab you tukar daripada banyak hole ke banyak elektron, so invert the area over there. Okay, so that's why nama dia inversion channel. Okay, any question up to here?
And then what happen if we apply negative?
Dekat sini?
At
Here?
At gate.
Okay, good. So let's see what happens if you apply negative. What will happen?
We will attract hole. A lot of hole.
Mm-hmm.
So the channel will be big, is it?
Apa?
The channel bigger.
Okay, so yes, you can make a channel of a hole. So this is not inversion channel. It's where, but okay, we will debate later whether we want to call it channel or not. So if there's a lot of hole over here, then what next? Can current flow?
Oh, the end got a minority of hole.
Huh? So it cannot, because this region, okay, because this region is still become P. So if this region become P, you still have back-to-back diode, right? So back-to-back diode, can you have current flowing?
No.
No. So the only way, so that's why the name is previously the name is channel, because why the channel works, because this here you have majority electron, N. So let's say kalau let me draw something you have N type. Tercantik siap semula. N-type material. If you want to gabung, you want for current to flow, ni you connect this to positive, dia you ground. There are, how, if I ask you this, if you have this this situation, how can you make the current to flow in this circuit? How? You can either put a resistor, right? So because N-type is like that semiconductor, when you dope it becomes like it can be conducting, so like metal, tapi dia tak conductive as metal. So it's like metal, but something need to connect them, right? So you can put a resistor. You can put a resistor here. Then current can still flow. But if you put a P-type here, can current flow? Cannot, because you come back-to-back diode. So you can either put a resistor there. Can you put a metal there? Can. You put a metal there, also you have current. Or you can put N-type over there. So if you put N-type over here, you have current, right? So what happens here is that we are inverting this place, this section over here, to become n-type, so that current can flow. Right, so that's why if you apply a negative voltage, it doesn't help because p-type is still, this will be p-type and then it will be back-to-back diode. Faham? Do you understand? Faham ke tak, Azam?
Macam kurang sikit pak tu, madam.
Macam mana?
Macam kurang sikit. Tak faham sikit yang
Apa yang tak faham?
how n-type, when we put the n-type, it will conduct.
Oh, sebab sama je kalau saya draw macam ni . Kalau saya draw macam ni ataupun saya draw macam ni. Sama tak? A and B.
Oh, sama-sama.
Sama je kan? Sebab tu dia panggil ni dia bagi jadi channel atau kadang-kadang dipanggil bridge. Is bridging the two source and drain. Okay? Any more question? Menarik tak? How just by buat macam ni, it can become you can control benda tu, and then manusia ni cerdik, Allah bagi otak kepada manusia, dia boleh control tu macam-macam, boleh buat lepas tu dengan BLSI, dia boleh buat gate, lepas tu dia boleh buat macam-macam proses yang sangat hebat, macam komputer awak semua tu, semuanya down to this MOSFET. Kalau nobody found the MOSFET before, tak ada harapan kita with all this technology nowadays. So it's a appreciation of the physics ni. Tapi physics ni, semua benda ni Allah yang membuatkan mereka behave macam tu. So Allah yang created mereka in the first place. Kita ni semua memahami je.
We supply positive voltage at D because we want accumulate electron at the surface of the D, right?
Yes. Yes.
Surface of what?
Surface of the drain.
Of the P ni. P.
No.
Substrate.
I mean the drain terminal, madam.
Kenapa drain terminal pula? Drain terminal ni kat sini ni semua memang N dah.
But why we supply positive voltage?
Oh, here you mean?
Yeah. Yes.
The reason why we apply positive voltage is for to attract, so that we have a flow of electron. Kalau katalah, so if you don't apply this positive here, you have the channel, but the electron doesn't go anywhere. There's no flow. Kan flow is what is it? Current. Current is
Flow of electron.
Flow of electron. So you need to flow from one place to another. So here by making it positive, you have a flow. The electron will be attracted to go here, and then there's a flow. Kalau tak ada positif, let's say kita tak apply positif, kita apply negatif, apa jadi?
Current will not flow.
Ya ke?
Yes, because it's separated. The electron is not continuously. The channel is separated.
Apa ni, kita still ada channel ni. So kat sini ni, I still apply a positive voltage here. I apply a negative voltage at the drain.
There will be hole accumulated at the surface of D.
Apa pun?
Minority hole.
At surface of P, surface of substrate ke D?
Drain.
Drain ni, brother, drain ni, semua ni N-type.
Minority hole, madam.
Tapi who cares? So minority hole, so what? Konsep dia ni N-type. Tapi saya rasa awak confused sebab kenapa awak confused? Positive voltage accumulate electron, right? Tapi kat sini, whether saya apply positive negative, there's no field effect over here because tak ada insulator. The field effect only happens when you have this insulator. So kata insulator is very important. Kalau dekat sini, there's no insulator. You just apply directly the negative to the N-type.
Then the flow of electron will go from D to S.
The flow of electron will be from
D to S.
Yes. So sebab dia be repelled away, so the electron will flow this way. So ada current. ada current.
Yeah.
Okay, so awak boleh apply, kalau awak nak suruh dia go the other way, you apply negative voltage. Tak ada masalah.
Okay.
Okay,
Madam,
alright. So,
Literally become a switch. Okay.
what the
no,
ground represent?
switch is when you have any current. Tapi switch, they don't really, current doesn't care whether it's actually what's direction. Any current.
No, I mean it's that if it's like switching on and off a circuit lah. It's like if we apply positive voltage to gate, it's like we are turning on a switch. If we don't apply, it turn off or
Yeah.
open circuit at that point.
Yes, but if you talk about the gate voltage, yes. But the drain voltage is just to whether it will be current or not. And okay, after this, so now you understand the basic. After this, we will go and increase the voltage. Tengok apa jadi. Okay, now you understand lah, basic ya.
Madam.
Ada
Why
soalan
we count
ke?
the source? Why do we count the source?
Tak dengar.
Why we ground the source? S.
Why you ground the source? You don't want to ground the source. What do you want to do with the source? Boleh juga. Awak nak buat apa?
What the function of the ground?
What is the function of the ground? Oh, that's a good question. It's actually a question for the whole 4 years of you being an electrical engineer. Anybody can answer me, Hambali's question.
To close a circuit.
Huh?
To close a circuit, to make a complete circuit.
So the ground actually makes, when you say ground, actually kalau belajar dulu ground tu, sebab ground tu dia bukan ground sahaja, macam kalau macam ni kita ada resistor, kita ada konsep of ground ni kan. You have resistor apa semua, lepas tu dia you ground. Biasa ni voltmeter. Betul ke saya pun tak lama dah. So you have that. So you ground here. So what happens is you have current flowing and dia dua ground dia akan bertemu. Dia bertemu dekat bumi. Interesting, tu pun satu benda kita patut reflect. Hebat lah Allah buat. Current tu boleh go through ke bumi tu, dia complete the circuit juga. Sebab tu bahaya kita ni kan, kalau kita pegang elektrik, benda-benda yang electric shock tu, badan kita dia akan complete circuit. Kenapa? Kalau kita pegang, badan kita tak sentuh mana-mana, dia hanging, dia takkan jadi apa-apa tau. Tapi sebab kita berdiri atas bumi, kita pegang benda elektrik ni, benda tu masuk, dia groundkan lagi, cukup complete circuit. Complete circuit, current flow, mati kita. You understand? Badan kita jadi tempat laluan untuk dia groundkan benda tu. So, Hambali, does that answer your question?
Yes.
So the ground will complete the circuit lah.
Yes. The ground will complete the circuit. Tapi katalah awak ni, saya risau je awak punya kefahaman awak terhadap elektronik dan elektrik circuit ni. Katalah kalau saya saja nak confusekan awak, saya tak ground ni. Saya buat ni positif. What will happen?
The electron will still flow from negative to positive.
Yes. So is the circuit complete?
Yes.
Yes. Why?
Because actually that's how ground works. You just change it's still ground.
It is still grounded because when you say positive negative, dia battery tu pun ada ground. So the battery itself, the voltmeter, panggil voltmeter tu, dalam voltmeter pun ada ground. So it will still in the end connected to ground. So okay, so awak faham lah konsep ni. Ni konsep first year. Inilah hidup kita ni. Kita kena repeat banyak kali. So alright. So any question here? Tak apa, tanya je soalan. Better you understand now. You don't understand now rather than later dalam exam ataupun dalam interview.
So, madam, the basic of this and most is we want to create the channel, and after that we supply the drain with positive or negative voltage in order to get the electron flow.
Yes, that is for NMOS. So kalau PMOS macam mana? You should know how a PMOS works. It's similar. So it's already 1 o'clock. So next class we'll go through a little bit on PMOS. I hope you will think about PMOS, how the PMOS works. So and the next ialah I will do is we'll talk about how to what do you call it? How does that what do you call it? How does this how do you get the characteristics of a MOSFET? Karakteristik MOSFET ni macam ni. Ni semua ni saya dah ajar, so boleh baca lah sendiri. Kalau tak faham, bacalah nota ni. Kalau tak faham nota saya, bacalah buku. So, do whatever as long as you understand. So, okay, mana karakteristik ni. So, kita next class kita akan, mana karakteristik dia tu? Yang ni yang kita tak cover, yang saya cerita apa nama energy band diagram, dia tengok wow. Yang ni saya decide tak cover lah, energy band diagram dia tengok punyalah complicated ni dengan different, you need to know work function and everything. Betul you change voltage dia akan bengkok macam ni. So tapi saya nak tunjuk yang graf tu, yang graf tengok masa first year tu kat mana? Tak ada pula kat sini. Yang ni ni. So we want to explain in next class how do we get this graph here, ID versus VDS, and then it will be here, and then it becomes saturation region. Why it becomes saturated? Okay, and in terms of physics. Alright. Okay, that's all.
Because of the electron repel.
We'll discuss on next class. Any question before we end? Tak ada?
All good, madam.
All good lah.
All good.
Yeah, all good. Okay lah. Yang betul-betul lah all good, you understand. So hopefully I really hope kalau orang tanya dalam interview, boleh explain, you know, how the MOSFET works.
For today, madam. For today. For today, all good.
Betul, esok hilang habis. Oh, ya Allah. Okay, let's end the class with the doa. Can I have somebody?
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين اللهم اغفر لنا ذنوبنا ولوالدينا وارحمهم.
Baca belahan sikit Faiz, selalu baca laju. Boleh baca belahan-belahan sikit.
اللهم اغفر لنا ذنوبنا ولوالدينا وارحمهما كما ربيانا صغيرا اللهم اكشف عنا من البلاء والوباء والفحشاء والمنكر والطعن والفتن ما لا يكشفه غيرك اللهم ارزقني في الدنيا زيارته وفي الآخرة شفاعته وفي الجنة رؤيته ومرفقته اللهم اجعلنا من الناجين والفائزين في الدين في كل امتحان في الدنيا والآخرة وصلى الله على سيدنا محمد وعلى آله وصحبه وبارك وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين.
Alhamdulillah Rabbil Alamin. Thank you for the doa. Kan sedap bacaan kalau perlahan-lahan kita boleh faham maksud dia. Okay, let's end the class with Tasbih Kifarah and Suratul As. Subhanakallahumma wa bihamdika nashhadu an la ilaha illa anta nastaghfiruka wa natubu ilaik. Bismillahirrahmanirrahim. Wal As. Innal insana lafi khusr illa alladhina amanu wa amilus solihat wa tawasaw bil haqq wa tawasaw bis sabr. Okay, see you next class. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, madam.
Welcome.